Welcome to Performance Tooling Secrets. I'm Mitch Bair, CEO of PTSolutions. Today, we're talking about grooving and cutoff operations. Specifically, how to do it without destroying tools, parts, or your day. Cutoff is one of those operations that works great until it doesn't. And when it doesn't, it's all bad. The biggest issue I see in shops is centerline. If your tool is dead on center or below center, downward forces are applied to the insert. And when that happens, here's what you see. Premature wear, bad finishes, out around parts, and a lot of heat. Worst of all, the chip breaker stops working, and poor chip control can cause huge problems. A better approach is to set the cutoff tool slightly above center. About 4 thousandths above center puts the carbide into a compression situation, which is exactly how it is designed to work. Now, the force is more radial, the chip breaker works as it's supposed to, heat leaves with the chip, finish improves, tool life goes way up. That's a win across the board. Here's a good rule of thumb. Raise the tool 1/1000th for every millimeter of insert width, but not more than 4 or 5 thousandths. If your machine has a Y-axis, great, just program it. If not, you're shimming. Now let's talk speed. Back in the 1900s, before CNC lathes, manual lathes ran at one constant RPM. Didn't matter what diameter you were cutting. CNC lathes gave us constant surface footage, or G96. With G96, RPM increases as the diameter decreases, keeping surface speed constant. Sounds perfect, but there's always a but. RPM can't increase forever. That's why we use G50, to cap the maximum RPM based on vibration, chuck limits, or safety. Let's say, for example, we're cutting off a 2-inch diameter bar stock, and we want to run at 400 surface feet and 5 thousandths per rev. We'll use G96, S400, and set G50 at 3,000 RPM. Everything runs great until we hit about a 1/2 inch in diameter. At that point, we've hit the max RPM. To maximize tool life and performance, we adjust the feed rate. At 1/2 inch diameter, reduce the feed by 20%, down to 4 thousandths. At 3/8, reduce it again to 3 thousandths. At 1/4, down to 2 thousandths. And at 1/8, reduce to 1 thou per rev until the part is cut off. It's a few extra lines of code, but the result is longer tool life, fewer breakages, real cost savings. That's worth it. For interrupted cuts, like square or hex stock, start the cut at 50% feed until you are past the interruption. Then kick it up to 100%. Apply these concepts and your cutoff processes become much more predictable. When carbide and cutoff blade prices feel personal, predictable is good. Thanks for watching. If you like the content, please like, share, and subscribe. Cut smart, cut safe, and I'll see you next time.